Hello and welcome to another Developer Essentials. So this time around, what we're going to be taking a look at is how we can have one object talk to another and look at the different ways in which we can do that. So starting to be able to discover objects in the scene and then interact with them. So for example, we could be doing that to find all of the pickups in an environment and then cause them to, be drawn towards the player. Maybe the player has an ability that pulls those things in. So we could be finding all of those. We could be using it from a AI point of view, so finding all of the potential things that an AI might want to interact with in the environment. So we're going to look at a few different ways of how we can approach doing this. Obviously, to begin with, we're going to, as always, need our general folders in terms of for materials and for scripts. And the initial thing I'm going to set up, I'm going to have a script that is going to be for the bounce manager. And then I'm going to also have another script for a bounce object. Bounce object. So the idea that I want to set up with this is I want to have a whole bunch of characters that what they're going to do is they are going to wait until the manager tells them to bounce, and then when they are told to bounce, they are then all going to bounce up into the air. So I'm going to create some materials here for the ground, and I'm going to go for grayish ground. I'm going to create some materials for the bounce manager. I haven't used yellow much. Let's use a really bright yellow for the bounce manager. And then for the bouncing object, let's make that, because again, I haven't really used an orangey color. So let's use an orangey color for that. So that's good. We've got our ground. Let's create our objects. So I'm going to say that the bounce manager is my sphere here. And let's just position that a bit above the ground. That's cool. And then I don't know if, actually I do have my script set up. So that is going to get its appropriate script on there and get renamed. So bounce manager. And then I'm going to set up a bunch of objects that are going to be performing the actual bouncing. So this is going to be bounce object 1. And let's make sure it's got the right material on it, which it does. Perfect, and let's make sure it's positioned suitably. There we go. And we offset it to about there. I'm going to make the ground a bit bigger while we're at it. So I actually want to arrange these bounce objects in a circle around the bounce manager. So what I'm going to do is I'm going to actually show you a really simple and easy way of spawning a bunch of things in a circle and doing this just in the editor. So what I need to do is I need to put an object at my pivot point. So at the point that I'm going to be placing all these objects around. Then I drag my object that I want to be spawning under that. And if I want to make it a little bit quicker, what I can do is I can pre-set up a couple of ones at different coordinates like this. These two would be at 0 and x, but one would be at -5. And another would be, at 5. So if I want a really cheap and easy way to then say, okay, well, I want ones at the 45-degree angle points, I grab the parent object, duplicate it, I rotate the parent by 45 degrees, and then what I can do is I can just bring all of these bounce objects out and then get rid of those temporary parent objects. It can be an easy way just for creating a whole bunch of extra ones there. So bounce object 2, 4, 6, 7, and 8. Cool, so I got all my bounce objects. I need them to have the bounce object script. So I can actually select all of them. And with all of them selected, I can drag my bounce object script over here, and that will attach that script onto all of them. So that's cool. They'll be able to now bounce. So let's think about what I want this script to do. So the starting point is, let's just actually get the bouncing logic in there. So let's just make it a really simple setup where we have bounce period. And this is something where if you want to try implementing this yourself, by all means, pause the video at this point, have a go at implementing it, and then come back. And the key thing is not that you match my approach. The key thing is that your approach works. As long as your approach works, it can be different to mine, and that is cool because you've worked out a solution, and then you've got another approach that you can look at and you can compare and you can see what's similar and what's different. It's not the case that my approach is the one and true right approach. It's not the case. There's so many different ways of how you can approach this, and there isn't one single, yes, you must do bouncing this way. If you have not, then you have done it wrong. That's not how it works. And to reiterate stuff I've said earlier, the most important thing when you're learning with coding is that you're able to make stuff do what you're after. Efficiency, performance, scalability, maintainability will come with time and practice. Early on, it's about making it that it does what you need it to do. So I'm going to go the approach of having my bounce period, so how rapidly it performs the bouncing. I'm going to say 1 second. Then what I'm going to do is my approach of, okay, vector 3 initial position, and then storing that. And then my bouncing here, my transform.position is going to be my initial position plus a new vector 3. It's going to be 0. This is where I'm going to have my bounce offset. And to calculate my bounce offset, I'm going to, we've seen this previously, I'm going to use mathf ping pong. So I can just feed in time.time and my bounce period. So I know that that means I'll get a value that goes from 0 up to the bounce period. So what I can do is divide that by bounce period. And I know I'm also going to need to control my bounce height. So bounce height. Let's say that's 1. So this is going to be bounce height times pi. So calculate the bounce offset. Use ping pong so it wraps with time, and then update the position. So what I want initially is just all of these to bounce. That's all I'm after to begin with. Is that this runs, and with luck, every single one of these just bounces. So that's pretty cool. That works. they're all annoyingly in sync, and I'm not a big fan of them being perfectly in sync, but we'll look at ways of fixing that in a moment. I'm also going to relocate our main camera so that it has a better vantage point. And let's rotate it so that it is looking at the scene. Down a bit. That's better. I might raise this up a bit as well and tilt it down even further. There we go. So, okay, they'll start bouncing at the same point in time. I want to make it that we now have a Boolean can bounce that starts at false to begin with. And then here, if we cannot bounce, then we return. This is equivalent to saying if can bounce equals false. So I'm using a shortcut here by saying not can bounce. That's a shortcut way of saying if I cannot bounce, then do nothing. Because what this will mean now is when I run it, nothing will happen. So none of these objects will move, but then when I turn on can bounce for one of them, it now is able to start moving. So that's cool, but I want to have my bounce manager control that. And what I want my bounce manager to do is I want it to kick off that bouncing for the objects. So I want it to pick an object and make it so that it can bounce. So this is where we get into the different ways of retrieving objects in the scene and having them talk to each other. So method one for doing this is, so method one, we're talking to other objects. It's not hard coded, manually linked data. So I would have a public list of bounce object target objects. So I could make use of this. So method one, we have this be hard linked. And what I do is in the bounce manager, we'll see I can then drag in object one, object two. If I expand this, we'll be able to actually see. So I can manually link this to all of the objects. So this isn't a bad approach, and it isn't something that it's a case of, yep, you should never do this. There are plenty of cases where I will often manually do linking up like this. The thing we always need to be conscious of is the time overhead with that. As I add in new things, I need to make sure I link them up. So there's a time cost there. There is also a failure point risk there in that, well, what if I forget to link one up? Will I know? Do I have the checks in place that ensures that that will cause a failure that I can easily detect and pick up on? Or is it something that is going to cause a more subtle breakage that could take longer to find? So manual linking up of things is completely fine, but we need to be mindful of the setup cost and the additional potential risk there with it. So I can set them up like that. And then, okay, this is going to be method one, talking to other objects. I'm going to make this be a little bit more obvious that I'm working. This comment is for a block of stuff. So make the objects bounce. This is a case where I do often use for eaches. It is something that's going to be happening fairly frequently, but not enough that I would worry about it. So target in target objects. Because target objects is a list of bounce objects, var, and we can see it's already filling in. It knows var will be a bounce object, which means I can get here and I can say, hey, target can bounce is true. So because the variable here is public, I can just directly set it. And then we'll have a look at a few other ways we can work with stuff like that. But I can just directly set it. So, okay, this will just do what we need. So what I can do here is when I run it, it will go and tell those objects to bounce. And if I remove one of them, so one of the objects will now not be told to bounce, and we can see what will happen. So, okay, cool. So that's one of the potential failure modes. We could have deleted an object, and how that will appear is like this. We'd get an entry that's none. So if I deleted one of these, its entry here would go to none. So let's see what that failure mode looks like. So in that case, this is what would happen. We get a null reference exception. So we need to keep that in mind that, as I said, we would need to put in failure checks here. So we would need to do things like, well, okay, well, if target is equal to null, then debug log error. One of the target objects is null. Check data setup. And you'll notice I'm not doing a continue, break, anything like of that. I am then letting it cause the exception. Again, going for that principle of we fail noisily with errors. We don't try and silently absorb the problems. We make sure the problems are made very visible so that they don't get missed and we're able to fix them. And something like of this, if we put in that null check without an error, we could easily suppress this problem, and we might not notice it until much, much, much later in the development, which makes it significantly harder potentially to fix the problem. So, okay, manual linking up, that works. But again, there is those failure points there with it. So this is method one, and I'm going to make use of some functions. Update method one. And the reason I'm going to do that is to make it just a little bit easier for me to split out the different methods that we have. So this is going to be update method one. And I'm going to comment that out now because we have another method for how we could do this. So what we could do is we can actually find those objects. So we can find them via a range of different methods. But one of the ones that we've got is find objects of type. We can also use find object of type if we just want the first thing, or if there's only one of a particular thing. So find object will give us back one. Find objects will give us all of the particular one. So we can say find objects of type bounce object, and then I can store that somewhere. So what I could do is I could say, hey, target objects, you're equal to find objects of type except target objects. In this case, that's a list, but this wants an array. It's a fixed set of stuff. So we're going to have method 2 for talking to other objects. Finding at runtime. So with this, I would have bounce object, and this is going to be found objects. So we'll do that. So we can search for them. Search for all objects of type bounce object. So anything that has the bounce object component attached onto it, it will return. So this is something where we need to be cautious if what we're searching for is, if I used transform there, for example, I would get back everything in the scene, which is not necessarily what I want. So I am going to shamelessly copy and paste. This is method 2. And the main reason I'm copying and pasting is because I just need to do that. Now I don't need to do a null check in this case because find objects of type is not going to give me back something that is null. And then I can run that. So method 2, I don't need to do a null check because find objects of type is only going to give me back valid things that it finds. So we can then run this, and what we will see is it finds all the things and it just works. If something was turned off, so say I turn that object off, and then it was activated later on, it gets missed. So find objects will only retrieve ones where those objects are active. If I turn off that component, so if I have the object on but the component off, we can see what happens. So if I then turn that on, then it's found it and it's fine because it'll return an inactive component, but it will not return a component on an inactive game object. So really, it's a subtle difference there, but it's an important one. If you are trying to retrieve something on an object that is turned off, so you've turned off the game object itself, the game object is considered to be inactive. Find object ignores inactive objects. If the component is turned off, so if it is not enabled, then it will still be found as long as its owning object is active. So that's an important thing if you're trying to search for stuff, that it will only give you back ones where those are attached to an active game object. Find objects, I could do this in the update. I'm intentionally not, because this is, in terms of the process of what it's doing, it's searching through every object in our hierarchy. Now, in our case, our hierarchy only has a fairly small number of things. We've only got a few different things there. It's going to be very quick for it to traverse that hierarchy. But a large game, it would not be unusual to have thousands, tens of thousands of things there. So a find object of type in that case is not going to be good for performance. It's actually going to be horrendously slow. So we want to avoid using find object of type or find object or find objects of type in an update unless we absolutely need to. So unless we absolutely have to because of that performance issue there. But it is a way where we can find something at runtime if we need to, which is cool. So okay, we can find stuff at runtime and we can be talking to the objects. But what do we do in a case where it is really slow, where we've got a lot of different ones? What we can do there is method 3 for talking to other objects. Registration at runtime. So we have a list of bounce object, registered objects. So the idea behind this is, okay, well, we need to be able to pick up things at runtime, but doing a find every update is way too horrendous for performance. But the objects, when they become active in the world, they could say, hey, bounce manager, I'm here. So we can do that. We can have the objects talk to the bounce manager and register. So I'm going to set up what the update function in that case would look like. So it just goes through registered objects. And we have our update method 3. But the key thing is, how do we have it maintain this registered objects list? Because when something is added to the world, we need to register. And when something goes away, we need to deregister it. So what we can do is we have a public void register object. And this is just what I'm calling it. We could call it whichever thing sort of best fit our project. So to register. So we've got a function here that this function, all it does is it says, hey, registered objects, add this one. And then we can have a deregister object and bounce object to deregister. And we remove it. So, okay, our manager object has this list. Manager object has two functions that can be used to maintain that list, so that it can be used to add things into it or remove things from it. Then what these bounce objects do is they need to tell the bounce manager. So we do that typically in start. So what we could do is find object of type, and this is where we use the singular, so find object, not find objects, because we know we only have one bounce manager. More than one bounce manager would be a problem, so we find object of type, we register an object, and we need to tell it us, because there's multiple different objects, and in each case we need to make sure it's referring to that particular one. So there's a way of referring to ourselves, which we say this. So what we are doing here is register ourselves with the bounce manager. So that will register it, which is cool. But what about this idea of deregistering? We need to know when this object is going away. So we can have on destroy. So for any of our scripts typically that we're setting up, as long as they're ones that say mono behavior here, we can set up an on destroy. And then that on destroy can deregister. So we are deregistering ourselves. So now, as soon as the bounce manager is there and active, it registers. As soon as it's gone, it deregisters. And we can chuck in that debug log here. Oops, not log format, just a log. Registering. To register. Now, to register, that's just a bounce object. I want to get the name of the game object it's attached to. So I can say to register, game object, name. And so that will work. We've got our update method 3, we've got our registry of objects. And so as they appear in the world, they will tell the bounce manager and it will be able to pick them up. So I'm going to have bounce object 8 turned off to start. So that means its start function won't run. So we can see we've registered objects 1 through 7. And this also helpfully illustrates the fact that the order the objects run start in is not necessarily what you would expect, because it's run for 4, then 6, then 7, and 5 actually ran last. So object 8, we make it active, and we see it registers at that point. Now, when we turn it off, it's not going to deregister at that stage. It would typically not deregister until we actually delete the object. So, okay, we've got different ways of working with this. And this is something we also need to watch for, is it might fail to find the bounce manager. Because again, the destroying of things, just as start, we saw that things can start in different orders. The destruction can also happen in different orders as well. So we need to make this potentially safe for running when this doesn't actually get a value back. And one way we can do that, typically, is put a question mark before the dot. So let's see what happens in that scenario. So it's running, made object 8 active. I'm going to then delete object 8. Then we're going to stop, and it's fine. So the question mark using question dot means only run the function deregister object if we found the bounce manager. On exiting the level, the bounce manager may have already been cleaned up. So that's something to be aware of. Bounce manager may have already been cleaned up. So using the question mark before the dot means that if the bounce manager has been cleaned up, it just won't run this function then. So 3 different methods of being able to have this communication happening between things. We can have our approach where we manually link up the stuff in the inspector. We can find things using find objects of type if it's a plural. So if we're retrieving multiple things, or find object if we are just retrieving one particular thing. And if we need to have stuff where it is dynamic, where we are being able to keep track of things as they are added and removed, then we can use a registration system where those objects, when they are added into the world, they register themselves, and when they are removed from the world, they deregister themselves, and we just work within a list of objects. So that's another way that we can be working with this. Now, when I was telling these objects that they could bounce, I was doing that by directly changing the variable here. That's something that I do want to potentially be careful about, and this is a good time to actually look at, well, what does public mean? Because we know when we put public there that it means we can access something in the inspector, but it also means that we can access it from other classes, from other files. That's why Bounce Manager is able to access can bounce, because we have made it public. So when you make a variable public, or as in the case here, we make a function public, there's actually an implicit agreement that you're making there. It's a contract where you're saying this thing is safe for anyone to change. That's what putting public there means, that you are saying that this variable is safe for anyone to change, this function is safe for anyone to run. And that might not always be the case. There might be reasons why you don't want particular bits of data being changed, because they might require a very specific sequence of steps, or because the way those bits of data change might have to follow particular business rules, for example, or logic rules, or there might be additional things you want to have happen when particular changes occur. You might want to show certain visual effects or sound effects. So there can be reasons why we don't want something to be public. Now, we might also want the best of both worlds and have something where it can be read publicly but not set. So we're going to look at a couple of different things. One of the things we're going to look at is, well, how do I make something so that it can be viewed publicly, something can read from it, but it cannot actually be changed publicly. It can only be changed within the class that owns it, and how we can then also set up some functions to be able to do that cross-communication. So my default that I will usually go for with variables is, unless I know that something external needs to be able to read and write it, I do not make the variables public. I specifically do not make them public. And so things like the bounce period and height, I don't want them to be public. I want them to be editable in the inspector, but I don't want them to actually be changeable outside of this file. So we're going to do a couple of things. I'm going to replace public with serialize field. Because what is happening here is using serialize field instead of public means the variables are still in the inspector, but are not visible to other classes. Because with that, if I tried, for example, in any of these, if I tried to, okay, well, target your bounce height, and it doesn't even appear because I have hidden it. I have made that data private. So I usually prefer to go for this approach of public variables unless I know other scripts are needing to access them. I make them serialized field rather than public. Something like can bounce that I want other things to be able to read from but not change. What I can do is after the name of the variable, I can do get and then private set. And we can see immediately Bounce Manager is grumpy. Because while I can go here and say, well, target can bounce, I can read from it. So I could debug log that. I can no longer change it in here. So using the get private set syntax makes this a property that can be read externally, but only written within this class. Properties are variables that can do extra logic when reading or writing them. So a property, in this case I'm using the can bounce property in a really simplistic way where I'm just making it a property so that I can control it, being able to be, allowing it to be read externally but not written externally. I could do further than that. I could actually make it that the proactive actually setting can bounce will cause it to, run particular effects, or it could do a calculation. So properties are variables that run logic when we get or set them, read or write them. But for now, we're using this in the very simplest method. So we'll also notice this then disappears from the inspector. So properties do not appear in the inspector. Properties are not visible in the inspector. So, okay, that's cool, but I've now created this problem where I've got all these things where I can't change that variable now, and that's fine, because I can set up a function here that this function could be called enable bouncing. And because this is within this class, it can say can bounce is equal to true. So I've got my enable bouncing, it'll set it to true, so I can come here then and I can say, well, target, enable, oh, but I can't see it. And I can't see it because I have not made this public. So just like variables have this ability to be public so anything external can see them, the same is true of functions. A function, unless we specifically say this is public, that function is not visible typically outside of the class. So by making it public, it is visible. So now I can do enable bouncing. And again, this is the reason for doing this approach where we don't just allow, make everything public and we can set those values, the variables in another class, anywhere at any time, is it allows us to enforce, for our code, to enforce rules for how stuff gets changed. It allows us to ensure safety. As I said, when you make a variable public or you make a function public, you are actually saying, you are advertising that yes, you can change this. You can change this variable at any point in time. You can run this logic, because that's the assumption that people will typically make if it is public. So that's not always the case. If we want things to be safer, then we want to make it that they cannot be just changed from anywhere. And that is going to make the program a lot safer. It's going to mean that it's harder to write code that is going to cause problems, because you've actually closed off some of the avenues that could cause problems. So for the final bit, I'm going to change this to serialize field as well. And we'll see when we go to the inspector, all of this still actually behaves, but can bounce will disappear. All of these still there, still work exactly the same way they did before. The only difference is that those can no longer be directly accessed from other files. So we've made the code a bit safer there. So just to recap, when we are accessing other objects, which we often want to do so that we can have objects talking to each other and passing information around, when we're doing that, we have different approaches. We can have a manually set up list where that is configured in the inspector. So we can use that. The key things we need to remember there is the potential overhead of every time we add or remove things, of making sure those lists are maintained. The potential errors of if those lists do become out of date, if we haven't maintained them, of how the code is going to behave in those cases. So that is an approach. It's a very quick one to set up, but it does have problems that we need to be mindful of when we're working with that. We can also discover objects. So we can use find objects of type or find object of type to retrieve particular things. Again, that's an effective method, but performance is a factor with it. So that's something where if we're doing that in large environments, it has to go through every single game object and look to see if it has that script attached to it. So it is quite a performance overhead potentially in large scenes. So it means if we're needing this to be dynamic, if we're needing it to be handling objects that can be added and removed from the world, then we probably need to go our third option. So the third option is we have a registry. So we have a management object that holds, here is a list of all of the things of this particular type. And then we have interfaces on that manager for registering and deregistering. And then the objects manage that registration themselves when they are added into the world or when they are removed from the world, taking into account that the manager might be destroyed before us because we don't have control over that to a great detail typically. So registration is what you would use for very dynamic environments. It's going to be much more performance efficient, and it has the advantage of you can't miss something, because as long as it's got the script on it, the script's going to register. So both those, the discovery-based method of doing a find objects of type and also the registration, are not going to miss objects. So they are a bit more efficient. We also saw that we can start to control what things are able to access our data, and that we can have things public, but if we're making something public, then we're saying, this is safe for you to change. And that might not always be the case. So if we want stuff to be configurable in the inspector, but we don't want it to be accessible to other classes, then rather than putting public, we can put serialize field so that it will be properly saved and loaded and it will appear in the inspector. We saw that we can use a very simple form of a property where we are saying that it can be read So it can be gotten, but its set is private, to have something that can be read from any file, but can only be changed within the current file that variable is within. We saw that we can then, with that, make it that we could have a function, which we make public, as a means for being able to interact with and control that variable. So making use of public when we want things to be accessible to other areas, and otherwise not indicating anything there, so that they are what's considered private, so they are only accessible within a particular class. Again, it's about code safety. So again, further stuff that you could be doing with this is experimenting with this idea of having things that can register and deregister. You could combine this with some of the other things we've looked at for having stuff move towards targets, where you could have something where your different characters register and then they move towards a target that's been found. So you could have a coordinating manager for that as well. So you could have a whole bunch of targets that register, and then you could also have a whole bunch of things that are seeking those targets, and they talk to a manager, and the manager says, hey, yep, no, there's a target you can be heading towards, here's your target. So you could have communication from that point of view, and that would be a really great sort of extra way of extending this, of a thing to attempt there, that can give you some really good practice of combining this with things from the other projects. And that's, again, something I encourage folks to be doing, is don't use these projects just in isolation. Start combining stuff. Combine it with some of the camera or other things from other projects. This stuff in particular, if you are wanting to be setting up that idea of things searching for and seeking after other things, then the project looking at how to have objects move and rotate would be a good one to be taking a look at, because that does have objects moving towards another one. So you could use this to have those be able to find their particular targets. So yeah, experiment with the stuff, combine it, try different approaches. That's really the big thing to be embracing with this, is experiment with it. You'll run into errors. That's okay. It's actually better than okay if you run into errors. Running into errors is good. We want to run into errors because we need to run into errors to learn how to fix them. We need to practice with the code because we're trying to speak another language, and we don't get better at that without actually attempting it. And just like when you're trying to speak another language, you're going to get things wrong, and that's okay. We learn from it, we keep practicing, we move on. So dive in, attempt making some changes there, attempt building things, combining a few of the different projects. It's really going to help for building up the knowledge and understanding there. Thanks, folks. That is all for this video. If you're looking for the project, you'll be able to find it up on GitHub, and I've put a link to that in the description below. If you've got any feedback, any questions, please chuck in a comment. And if you're looking to find ways to support the channel, chucking in a like or subscribing to the channel is always a big help. If you're looking to go further than that, then I do have a Patreon set up, and any support there is super appreciated. And there's a bunch of different things that you'll get as part of being a patron there. And the big thing is, it's going to help me make more cool things like this, which is going to help more people like yourself to be making more games, which is awesome. And that is all for now. Thank you.